The last part that you learned about was about how to convert units, and we did some silly problems that didn't really have a lot to do with chemistry. We're going to learn how to convert units that do relate to chemistry, specifically to the metric system. The metric system is also sometimes called the SI, system of measurement. It's used most often in science, and it's a pretty useful system because everything is based on decimals, or powers of 10. When we talk about metric units, they have two parts. There's a prefix and a base unit. So if the base unit, say, was meters, that could have different prefixes attached to it. I could be talking about kilometers. I could be talking about centimeters. I could be talking about millimeters. So I can put a prefix in front of my base unit. Now, base units in chemistry. This is a slide that you need to memorize. Mass, the base unit is the kilogram, and its symbol is kg. For length, the base unit is the meter, and its symbol is a lowercase m. For temperature, the metric unit is kelvins, and its abbreviation is a capital K. We'll also talk about Celsius and Fahrenheit. Those are other temperature units, but Kelvin is actually the metric unit. Time is seconds, and that's an abbreviation of S. Amount of substance, that's the mole, abbreviated MOL, and that will be the subject of the next lesson, lesson 4. Electric current is amperes. You've probably heard somebody talk about amps before. That symbol is A. And the light brightness is candelas, and that symbol is CD. I just usually remember that candles give off light. You can also have what are called derived units in chemistry. Derived units just mean that they're made up of other units. So something like if I was talking about the area of a room, I would have to do length times width to find the area. And if I'm finding length in meters, then length times width would be in square meters for the area. For volume, volume is length times width times height, so that would give me meters cubed. So area is squared, volume is cubed. Another unit of volume might be, if I was talking about liquid volume, I would probably use liters. I think that cubic meters would be more like the volume of a box. Pressure is in pascals, energy is in joules, and frequency is in hertz. You should know these derived units as well. Okay, metric prefixes. We finally come to this, and I put this slide into the Lesson 3 worksheet so that you would have the prefixes written down somewhere. You need to memorize these prefixes. You need to know them forwards, backwards, and upside down. Prefixes are something that you're going to see all semester. Your book has a table of the metric prefixes in it, and I wish that you would please disregard the table in the book. What I've given you here, I've tried to give you something that I think you can use more. Also, the book uses more metric prefixes than we need to know for this course, so only the prefixes that are on this particular slide are ones that you need to know. The way that I wrote out this table, I have base units here, sort of in the middle of the table. A base unit is any metric unit that you can slap a prefix on the front of. So base units are things like grams, meters, moles, liters, seconds, joules, pascals. Those are the most common base units. And it would be possible to put prefixes on the front of those. Meters is probably the easiest example to do this with. I could talk about kilometers. I could talk about centimeters. I could talk about millimeters. Meter is the base unit, but I can put prefixes in front of it, and I can talk about all sorts of different sizes of things. The other way I set up this chart is base unit is sort of here in the middle. Everything written above base unit, these are all larger units. They're bigger than that base unit. Everything written below base unit, these are all small units. They are smaller than the base unit. You need to know the prefix, you need to know its abbreviation, and you also need to know the conversion factor, because that's what's going to help you actually solve problems. So mega is a capital M, and mega means million. If you remember your scientific notation, 1 times 10 to the 6th would be a million. So I'm going to say that grams was my base unit, So I could talk about 1 megagram was equal to 1 million grams. Remember that this is a big unit, this is a small unit. The 1 is always going to go with the big unit. So 1 megagram would be equal to 1 million grams. The next unit to know is kilo. Kilo is a lowercase k, and I could say 1 kilogram was equal to 1,000 grams. Kilo means 1,000. Remember that kilo is the bigger unit, so that's why 1 kilogram is 1,000 grams, because one big unit is going to be equal to 1,000 of the smaller unit. Hecto, abbreviated a lowercase h. Hecto means 100. So using grams as my example, 1 hectogram would be equal to 100 grams. Then we come to deca. Deca sounds kind of like decade, right? So deca means 10. 1 decagram is equal to 10 grams. So now we come to units that are smaller than the base unit. So we have deci. Deci also means 10, but in this case, 1 gram would be equal to 10 decigrams. Now the base unit is going to be the bigger number, so that's why I'm saying 1 gram, because the 1 always goes with the bigger number. 1 gram equals 10 decigrams. One larger unit equals 10 of the smaller unit. Centi, lowercase c is its abbreviation. Think century. A century has 100 years, so centi means 100. So let's say that 1 gram would be equal to 100 centigrams. Milli, think millennium. A millennium is 100 years. Sorry, a millennium is 1,000 years. 1 gram would be equal to 1,000 milligrams. Micro. Micro has this funny little symbol. It's the Greek letter mu, and it looks sort of like a funky, strangely written U. 1 gram would be equal to 1 times 10 to the 6th, or 1 million micrograms. So micro means million. The last one to know is nano, abbreviated with the lowercase n. 1 gram would be equal to 1 times 10 to the 9th, or 1 billion nanograms. Nano and 9, I can remember in my head that those both start with n, so they seem like they're the same. Now, I just used grams in all of my examples, but you could do this with any unit. I could talk about centiliters. I could talk about milliliters. I could talk about hectoliters. You can put these prefixes in front of any of the base units. Here's an example problem, what one would look like. We're going to use that conversion factor method again. So I'm reading this question, and I want to find the number and the unit that are part of the question. 2.44 meters. Okay, so that's my starting point. I want to change meters into centimeters. I know that I need to get the unit meters to cancel. So if I started with meters, in my conversion, meters needs to go on the bottom, and I'm changing it to centimeters. So meters on the bottom, centimeters on top, because that way the unit's meters will cancel out. I have to ask myself, which one of these is the bigger unit, meters or centimeters? Meters is the bigger unit, so that's why I put the 1 on the bottom where meters was. And then I thought about it, and I thought, oh yeah, centi means 100, so I put 100 on top. So my math is 2.44 times 100 equals 244. Remember, to solve the math, you multiply all the numbers across the top, and you divide by any numbers that are on the bottom. This was an easy problem. It only needed one step to solve. You can also do problems that are more than one step. Now, if my question says convert 2.6 kilometers to millimeters, I got to stop and think for a second. Kilometers and millimeters, neither one of those is the base unit. Meters would be the base unit for length. So you got to think, I can't go straight from kilometers to millimeters. Every problem has to go through the base unit. So I'm going to add an extra step into the middle of this problem. What I'm going to do, I'm going to take the number in the unit that they gave me in the question. So I have 2.6 kilometers to start with. I need to change things to the base unit because every problem is going to need a base unit in there. So kilometers is going to go on the bottom. I'm going to change it to meters because meters is my base unit of length. Now I have to ask myself which one's bigger, kilometers or meters. Kilometers is the bigger unit, so that's why the 1 went on the bottom where kilometers was, and kilo means 1,000, so the 1,000 went on top. This is my conversion now. 1 kilometer was equal to 1,000 meters. So kilometers on top, kilometers on the bottom cancels. Now I need to do a second step. I need to change meters into millimeters because the question really wants me to end up in millimeters. So I've got meters on top. In my next step, I put meters on the bottom. I put millimeters on top. I have to ask myself which unit is bigger, meter or millimeter. Meters is bigger, so the 1 goes on the bottom where meters is. Milli means 1,000, so the 1,000 goes on top. So to solve, it's 2.6 times 1,000 times 1,000, and you would divide by anything on the bottom. So this is my final answer in millimeters. It's also possible to do conversions between our English units and our metric units. There are 3 conversions that you need to memorize. There's a conversion for mass, so 454 grams is equal to 1 pound. There's a conversion for length. 2.54 centimeters is equal to an inch. And there's a conversion for volume. 0.946 liters is equal to 1 quart. An example of using this. An iron sample has a mass of 4.5 pounds. What's the mass of the sample in kilograms? So, I need to read the question, and I need to find the number and the unit that are part of the question. That will always be my starting point. So I see 4.50 pounds. That's my starting point. So I begin with that. Now I need to find some way to change the English unit pounds into metric. So I'm going to use the conversion that there are 454 grams in 1 pound. So I started with pounds, so pounds needs to go on the bottom in the next step. Grams would go on top because that's the unit that I'm changing to. 1 pound is 454 grams, so I put those numbers in. The next thing to do, now that I have it in grams, the question's a little hard because the question wants me to give my final answer in kilograms. So if I have grams on top here, I would need to put grams on the bottom in the next step, change it to kilograms. I've got to ask myself which one's bigger, a kilogram or a gram. Kilogram is bigger, so I put the 1 on top where kilograms is, and kilo means 1,000, so I put 1,000 on the bottom where grams is. So to solve this, on my calculator I would plug in 4.5 times 454 divided by 1,000. You multiply the numbers across the top, you divide by the numbers on the bottom. So 2.043 kilograms is my final answer. Guys, remember that I don't care too much about how you round at this point. So as long as you're getting answers that are close to mine, if you round it differently, it's okay. It's not a big deal at all.